Strength of materials. Material strength is the ability of a material to retain its structure when subject to stress and strains. One of the types of material strength is tensile strength. It is a resistance to being pulled apart. A material with a high tensile strength resists force that would act to make the material expand. For example, pulling a rope from both ends until it stretched is a test of tensile strength.
In this session, we want to have a better understanding of what happens when shear force is applied and develop a method of calculating the shear stress in the beam. As you know, transverse forces are loads that are applied perpendicular to the axis of the beam. In order for you to visualize this, I want to show a demonstration. I have a few pieces of steel with me. I want to show you that the edges of steel are fully aligned. I'm going to hold them together and apply a transverse force. As you can see, this causes bending, but you can also see that the pieces of steel also slide relative to each other. Take a closer look at how the edges are out of the alignment. This means that each steel is experiencing shear stress in the longitudinal direction. This shows that the transverse force I applied not only creates shear stress along the vertical plane, but also along the longitudinal plane.
Bulk modulus. The bulk modulus is a constant that indicates how compressible a material is. It's the ratio of material's volume loss when pressure is increased, because a compressed material returns to its original volume when the pressure is released. The bulk modulus is considered a descriptor of elastic qualities. Sponge or foam is one of the examples of bulk modulus, which means that the volume of foam reduced without changing its shape, even you put a lot of pressure by squeezing or pinching. And by the time when you release the pressure applied, it will automatically return to its original shape.
Strength of materials. It typically refers to various methods of calculating the stress and strain in structural members, such as wood and other types of materials. For example, if a wooden stick is thick enough, it would be harder to break because it would require more tension and shear stress to break the wood in half. But if the wooden stick is narrow, it would be easy to break because of its size.
What is a fluid? Fluid is a substance that deforms continuously under the action of shear force. A fluid may be a liquid or a gas. It offers resistance to a change of shape and it's capable of flowing. So next is, what is fluid mechanics? Fluid mechanics deals with the study of all fluids under static and dynamic situations. Fluid mechanics is a branch of continuous mechanics which deals with a relationship between forces, motions, and static conditions in a continuous materials. This study area deals with many and diversified problems such as surface tension, fluid statics, and flow in enclosed bodies or flow around bodies, flow stability, and etc.
Example of fluid mechanics. If you open this, the water will comes out, or there is a flow of water because of the pressure of the water above it.
Another example of applying the concept of fluid mechanics into our everyday life is using a lotion or any product which is inside a container. So when you squeeze the container to get the lotion or what is inside it, you are actually applying a pressure force to the container. In addition, once the container is set upright, the lotion slowly slips down the side of the container. Since the lotion is coming into contact with the sides of the container, shear forces are present. So this situation is representative of a co-wet flow.
Next example of fluid mechanics is toothpaste. Today, as I brushed my teeth, I was reminded of the extreme difference between the viscosity of water and the viscosity of the toothpaste. Water is a Newtonian fluid that has a very low viscosity and flows freely at room temperature. My toothpaste, on the other hand, has a very high viscosity. It is actually considered a non-Newtonian plastic fluid because a shear force must be applied to it before it will move. This works to my advantage when I brush my teeth. Think how hard it would be to put toothpaste on your toothbrush if it just poured out of the container when you open the cap.
One example of fluid mechanics is the waving of a flag. The wind blowing on the flag produces a drag force on the flag. This force acts on both sides of the flag. This drag is due to the wind blowing over the side of the flag. The force itself is the shear force acting on the flag. So, waving of a flag is an example of fluid mechanics.